Good morning, everybody. We're back. Brandon Steckler, technical editor of Motor Age Magazine, here for Wrench Tales episode number 7 with my good buddy, Ryan Colley of Elite Diagnostic Solutions in Taunton, that's Somerset, United Kingdom. How you doing, my friend?
Yeah, doing so well. Nice to see you again. It's been a while. How's
Good to
things?
see you. Good to see you too, my friend. It has been a while, and we got something coming up in the near future. I'm excited
Yeah,
about a class we're
yeah,
going to be doing all over UK.
yeah. So we have I think a week away. I think you are. I think a week, maybe two at most.
Yeah,
We got to jump on the plane, and you'll be over here doing some training over here in the UK. So yeah, that's gonna be a blast. I can't wait to see you.
likewise. Uh, I talk too much, and I've got friends all over the planet. I'm very fortunate for that. Friends like you, Ryan, and Ryan and I became acquainted over a story. This exact story Ryan and I are going to be telling today. It's pretty neat how it happened, and what I'm proud for is that uh, through this collaboration on this vehicle we're going to be talking about, Ryan and I established a cooperation, if you will, between the United States and the United Kingdom for training opportunities for technicians. And it's been going really, really good so far. I'd say it's been, heck, 4 or 5 years at least, hasn't it?
I reckon so. Yeah, at least 4 or 5 years. Yeah, long
Yeah.
time.
So the the vehicle, the story I'm talking about is pardon the play on words, a jump across the pond. Um, it's a pretty interesting story. Ryan was faced with this vehicle in his shop. Ryan's a very successful entrepreneur. How old are you, my friend?
I'm 29 now. 29. Yeah,
29. So he was he was 24, 25 years old when I met him. Owns his own mobile diagnostic business. He owns his own brick and mortar shop in the United Kingdom. He owns his own training and tool company called Elite Diagnostic Solutions. His shop is Elite Automotive Diagnostics, and he's just making a tremendous way for himself. So I'm proud to know you, my friend. And this vehicle came into his shop with some runnability complaints. It wasn't running too good at all. As a matter of fact, it was running pretty terrible. And what makes this vehicle different? This was a 2006 Audi A4, if I'm not mistaken, wasn't it?
that's correct. Yes, yeah. 2006 Audi, yeah, A4.
And this vehicle is configured with an engine. I think the engine was designed for Lamborghini, if I'm not mistaken.
That's
A big
correct.
V8 engine. And what makes this engine unique, I don't want to say unique, but a bit cumbersome to address, is how the engine's assembled, how it's configured, where certain components are located is what makes this vehicle tricky. So to start off the story, I just want to say when Ryan reached out to me, it's because Ryan had some information that he collected from the vehicle, some diagnostic data that he and I collaborated on as far as analysis goes, because he had a very important decision to make. Ryan, tell me a little bit, if you don't mind, about this vehicle. When, if you can recall, when the vehicle came into your shop, what were you faced with? Tell
Okay.
us that backstory there.
Sure. I mean, the vehicle came into us, running very poorly. It was obviously had multiple misfires. The customer himself, taking the vehicle elsewhere, they was advised that it had multiple misfires, that it had new coil packs and it had new spark plugs. The issue was still present. The garages weren't too sure exactly what was going on with it, so then they forwarded it over to us. We took a look at it. Obviously, started with an initial scan. Read the fault codes in it, and it was obvious to us. We had so this vehicle has a V engine, so two separate banks. It was obvious to us we had one whole bank misfiring. Um, all of
And you
this,
can see that right from scan data, right? The
correct.
information
Yeah,
you gather. Okay.
yeah, so obviously, straight scan, you could see it. If you cleared the fault codes down, starting the car up again, the vehicle would run very poorly, and all of the fault codes, the misfires were coming straight back. So again, a really obvious straightforward, in a sense, diagnosis. We know where we're headed. We have misfire, so we now need to dig in a bit deeper and find out exactly why is the vehicle misfiring and why is it only on one bank. That's the question, and the we need to figure out.
Now, I got to ask you a question. What did the other shops tell this customer? What would have been their suggestion, or what was their suggestion after they've done what they've already done?
So obviously they changed the coil packs and they changed the spark plugs. Their next suggestion was to change all of the fuel injectors for that engine. And then after that, if that didn't fix it, they said it needed a replacement engine, on a guess. And this engine is very expensive, probably in excess of eight to £10,000, and that's probably about 13,000 dollars, I would expect, roughly. So a very, very costly repair, and for the vehicle being 2006 model, the chances are the customer wasn't going to go ahead with it, and they're probably going to get rid of the car. So they brought it over to us kind of on a last whim, hoping that we could potentially give them some good news and not give them such bad news, and kind of go from there, really. So we sort of dug into it. I say we done our initial diagnosis, which was obviously get the fault code and gather some sort of a test plan. We got to the point where obviously we knew we had a misfiring on all four cylinders. The basics had been done, ignition, if you like. They'd ruled that out. Obviously we had a potential. It could have been. It's unlikely to have four injectors failing, so we need to use our common sense a bit and perhaps move forward from that. So the next quickest thing to do really would be to do a relative compression test. Brandon's just popped up the relative compression test on here, and you can see quite clearly we have a issue. So obviously on the capture here, we should have even peaks and troughs. And what we can see is quite clearly we have a few that are missing. So we have four good ones. Yes, this is a V8 engine. So four good ones and four bad ones from memory. Yes.
And here's I want to back up and restate that this poor fella, your customer, your client, is on the fence about getting rid of the vehicle because of the cost of repair. So I'm not trying to point fingers or call anybody any other shop incapable or something like that, but we have a responsibility as technicians and our customers. If we're fortunate, our clients, our customers trust our judgment, and if we tell them the vehicle needs an engine replaced, that's a really bad day for the customer. And I understand why a shop would say something like that, right? That's the I don't want to say the easy answer. I mean, but if we give them that answer, chances are we're going to solve the problem, even if it's something we could maybe repair. We've taken a lot of the risk off the table by selling them the entire engine. So I get it, but there's a better way of doing it. Now, I just want to recap on this capture you have here and what it's telling us, just like you said. Clearly, we've got peaks and troughs, or peaks and valleys, sometimes we call them here in the States. The peaks are all the same, and I've taken the liberty to color the gray ones, sorry, the tall peaks gray, just as a visual point of reference. So if you're unfamiliar with a relative compression test, you know what Ryan and I are referencing. And you can see all the ones I've had colored yellow, those peaks are clearly much lower. Although they're even, they're much lower than the gray ones. But here's what this tells you and I. And Ryan, tell me if you agree. The information in front of us simply tells us four cylinders are relatively lower on compression than the other four. Does that
Absolutely.
answer? Yeah, does that answer our question? Uh, no, it confirms we have a mechanical problem, but it doesn't really tell us what the issue is. And quite frankly, at this point in time, many technicians will say, well, if we had an issue on one bank, um, every other cylinder or every other peak would be low. In other words, we might have a gray one here and a yellow one here, and then a gray one here, and then a yellow one here, and they would alternate back and forth. And that is true in many, many scenarios. But that's not what we're seeing here. And that's why I've called this a peculiar looking waveform, because there's a piece of information we're missing here. We're going to learn that as time goes by. But so here's what we're faced with, right, Ryan? I mean, clearly the engine's, I'd say, out of time. We've got one bank that's out. Maybe not. Maybe it's not out of time. Maybe we really do have four cylinders that are damaged. Um, Maybe it is out of time and the cylinders sustain some damage. We've all seen vehicles where the timing chain, the timing components become unsynchronized, and pistons come in contact with valves, or intake valves come in contact with exhaust valves, and they cause physical damage to the engine and requires replacement. And I guess this might be the reason why the shop suggested potential engine replacement to solve this issue. But here's when I mentioned configuration. This is what Ryan told me. I was thinking of Ryan as he and I collaborated over this data. I said, what's the big deal? Why don't we just go ahead and investigate further? And he educated me. I don't work on many European vehicles. I address them from time to time, but I just don't spend much time on them. So I certainly wasn't familiar with this power plant. But this is what Ryan told me. He said, all of these timing components are located in the back of the engine, not in the front like we typically see on most engines. It's in the back, meaning it's sandwiched between the transmission and the back of the block and cylinder heads. So this is the repair here, right, Ryan? You'd have to drop the entire powertrain down onto the ground and
Yep.
separate the transmission from the engine simply to access these components, only to replace them and potentially find out that you've done a great job, Ryan, but the damage is already done and the engine requires replacement anyway. Two problems with that. One, the customer doesn't want to hear they have to spend several £1,000s for you to carry out this work, only to find out, hey, the other shops were correct. You do need an engine. And I'm sure certainly you don't want to eat the cost of this repair. So this is where you reached out to me, right?
Correct. So
You,
obviously
you,
we're getting, sorry, jump in there.
please.
So we're getting to the point now where we know an engine mechanical problem, and obviously we're tasked with speaking to the customer and saying to them, look, we need to either do more testing to identify exactly what's causing this problem, or we don't want to be guessing really. It's going to cost you, like I say, thousands of pounds to repair this vehicle, and then what if the valves are contacted perhaps, or there's a bottom end issue of the pistons or con rods or whatever it may be, or crankshaft. I mean, up until that point, we needed concrete evidence to prove that if we're going to take this engine apart, we can fix it, we can put it back together, and it's going to work. And we don't want to be doing any repairs to this vehicle up until that point. We're 100% confident it will be a-okay. So I then reached out to Brandon and said, this is kind of what I'm tasked with. I seen Brandon initially on a Facebook forum, actually posting some captures and stuff and getting people involved and thinking, outside the box, and what can we think and achieve from this capture and gather information wise. And that's what kind of set it off really. Up until that point, I was quite blue to all this, quite new really. I've seen it been done and I've delved into it a little bit, but nothing too crazy. But I could obviously see Brandon had been doing a lot of stuff on this. So it made sense to reach out, use our contacts if we can, and ask for help, effectively ask for help, see what Brandon thought, and then we could come together. I was quite happy to do the testing, that's not a problem, but putting the puzzle pieces together was where I needed a hand. So I reached out to Brandon and very, happy I did. Obviously 6 years later, and we're still working together on loads of different stuff. And sorry, I sidetracked a little bit. But
No,
yeah,
you're fine.
we got there in the end. So obviously reached out to Brandon to help me. We sent over some captures to him, which what we needed to do was with a specific piece of equipment called a oscilloscope, obviously, and a pressure transducer, which basically measures pressure in what's the best way to describe it?
Different areas.
Yeah, it measures pressure and then converts it to a voltage so we can see it on a scope and then we can basically make decisions based off that information. It's
Yeah,
not
and
carry on, brother, sorry.
that's okay. And some many technicians are overwhelmed by this technology because there's a steep learning curve. But once you have some known fundamentals about engine mechanical functionality, you can start to see the interaction between the engine and the pressure transducer through the signals that you see on the scope screen. So Ryan again reached out to me as he's just described and told me the story, and he said he's captured some information. Would I be willing to guide him through the analysis process? And I'm glad he did because we both learned a few things here. And that's exactly what we're doing. So first thing he sent me, obviously the relative compression capture. I agree with him 100%. We had an issue on four cylinders of the eight, but the question was, why didn't the relative compression capture alternate from a high peak to a low peak and back to a high peak again, if in fact we had maybe a timing fault? He and I both were under the impression it should alternate if we had a timing fault from one bank to the next. He had captured here with that pressure transducer, he simply connected it to the intake manifold, which didn't require any disassembly. It didn't require any really true investment of time to gather this information. And that's probably the best part. We can use this information like stepping stones, even if the shops were correct that said, hey, maybe it's best we replace this engine. Ryan can do so with a bit more confidence and integrity because he's not giving them his best guess. He's basing his information scientifically off gathered get data and an analytical process. So this next capture here is from the intake manifold, and it reflects something very similar. We've got what you see here, the yellow dot is high on this one and low on this one in gray, and then high again, and then high again, and then high, and then low. So things are not basically alternating from one bank to the next. And again, um, are we assuming we have a loss of time? Yeah, but we can't really explain right now why it doesn't alternate. So we did a bit more digging, and we found a capture here in service information stating not only the engine's firing order, but what's also important is the engine configuration. Because if you look at this engine, my friend, bank one would be the one that houses cylinder number one, and the cylinders count off one, two, three, and four. Where with other configurations, this could also be cylinder number one, but that would make this one cylinder number two, and then this one cylinder number three, and then four, and then five, six, and seven, and eight. So how the engine's configured is just as important as the firing order itself. And this was the key piece of information that answered the question regarding Ryan's relative compression capture and his intake waveform capture. So if you look here, using a piston chart, a tool that helps me identify specific events within the 720-degree or one complete engine cycle, I've built the chart according to the firing order and according to a point of reference that Ryan chose. It would be an ignition event for cylinder number one. You can't see it right now because it's covered up by this chart, but it's beneath this chart right here and right here. And these vertical cursors represent partitions. We've taken this we've taken this capture from an 8-cylinder engine and we partitioned it 8 different ways. And why we are doing that is because we want to see how each one of the cylinders, each one of the 8 cylinders, contributes to the intake manifold. My thought is this: whether you are familiar with this type of testing or not, I know all of you are familiar with the fact that this V8 engine, that all 8 cylinders should perform the same amount of work. Meaning, if we are looking at changes in pressure within the intake manifold, all the pressure changes should occur pretty much the same uniformly for all cylinders. just like a relative compression test. And we're not seeing that. So what this chart helps me to do is determine where these, what I refer to as poles, where a negative change in pressure or a decrease in pressure occurs. That's from the vacuum from a piston pulling on the intake manifold or inhaling air from the intake manifold. This point here where it changes direction and heads down is referred to as a transfer point. So the transfer point, I want you to look at this. The transfer points are the colored dots that we have here. I want you to look at the proximity of this yellow dot relative to this vertical cursor. In other words, if you laid a ruler out here and measured this distance, look at that distance here. And then look at this distance here. It's approximately the same. And you'll see the same here for cylinder number 5 and cylinder number 8. So 6, 7, 5, and 8, those are all bank 2 transfer points. Now I want you to look at the gray ones. Look at this proximity. This gray one, proximity, is similar to this one, as well as this one and this one. These are transfer points for 3, 2, 1, and 4. What am I getting at? All the gray dots represent transfer points for bank 1. All of the yellow dots represent transfer points for bank 2. What does that mean? All of bank 2 transfer points are late relative to bank 1. So this confirms we, in fact, do have a timing fault. And if we go back to relative compression, what does that have to do with low compression? Why would I have low compression if I had a timing fault? That depends. It depends on engine configuration. And what I mean by that, particularly, is the camshaft configuration. The intake valve is responsible for harnessing the air within the cylinder. So if you look at this syringe right here, that piston represented here by that plunger in the syringe, if we were to cover the end of this syringe up so no air could leak out of it, we would build pressure as this piston moved forward. But if we move the piston forward and we left this opening exposed, we could displace air. Air would not be trapped, so we would not build pressure. So what I'm getting at is if we have late intake camshaft timing, or we have late camshaft timing and that camshaft operates an intake valve, that's probably more accurately stated, as long as that intake cam is late, the intake valve timing is late, and we will trap less air in the cylinder. So what I see here is low compression for cylinder number 5, low compression for cylinder number 8, low compression for cylinder number 7, and low compression for cylinder number 6. All of bank 2 is late. Now the question becomes, do we also have damage, physical damage to the engine because of this shift in timing? We've proven that the timing has shifted. If Ryan takes this engine apart and replaces the timing components, he will find that the timing components are out of time. The camshafts are not within time to the crankshaft for bank 2. But Ryan is more concerned with now, if I replace these timing components, if I invest 30 hours of labor and several hundred pounds in timing components, is it really going to fix the car? Or is the car going to have an underlying problem due to a mechanical collision between the valves in the piston or between the intake and exhaust valves? That's really what we're faced with, aren't we, pal?
Absolutely. Yeah, absolutely right. Yeah.
So we've gathered
Sorry,
one
Carl.
more piece of information to put what I'll call the final nail in the coffin. Ryan committed to removing a spark plug from bank 1 and capturing pressure data, almost like a compression test with a gauge. And he's done the same thing for bank 2. And clearly they're reflecting differently. Bank 1 is showing about 104 pounds per square inch here, where bank 2 is only showing about 60. But we know the low compression is due to a timing shift. More importantly, what we do see here is that the cylinder can draw a vacuum on bank one, and the cylinder can also draw a vacuum on bank two. I know you can't see this number here. I'll try and zoom in on it a little bit. But the vacuum here is almost minus 10 psi, which is about 20 inches of mercury for the good bank. And for our suspect bank, it's about minus 13 psi, which is almost 25, 26 inches of mercury. This is very close to a perfect vacuum. Ryan, even if you know nothing about pressure waveforms, if you had a enclosed area and you had an area that wouldn't seal, would you be able to draw a negative pressure or a vacuum in that cylinder?
Absolutely not. No.
No. So what I'm getting at here is Ryan just answered his own question. The fact that we can pull a vacuum in that cylinder states clearly that there's no way that cylinder is leaking. And that's very good news for us because, Ryan has his answer here. Well, what did this give you confidence to do, my friend?
Absolutely. So as you can see from the two captures just then, um, yeah, so we can see that we have good vacuum, obviously on both banks. More interestingly, obviously on bank two, which is obviously our faulting bank. The vacuum obviously being built in that cylinder confirms that the integrity within the cylinder is fine. We obviously can't build vacuum in a cylinder that's leaking. So to confirm, it's not on this capture here, but I did do the same test on all cylinders just to confirm that we had good vacuum on all the four cylinders that were faulting, just in case there was something funky going on one of the cylinders and we didn't want to take any guesses. So we needed to be 100% accurate with this. So I measured every single cylinder on the bad bank and we had good 25 inches of mercury roughly of vacuum on each cylinder on that bad bank, which confirms that each and every single cylinder on that bank is sealed. It's not leaking.
Absolutely. That's what we determined. That's solid piece of information. You are light years ahead of the other surrounding shops that evaluated this vehicle because you don't have to sell this customer an entire engine. You've probably given them the best news they've heard all month that you can fix this car, relatively inexpensive compared to what the cost of an engine replacement would be. And while we're on the screen, I just want to point out I've annotated this. Of course, looking at this screen the way it is, you can't tell at home the timing here. But where pressure starts to build is proof that the intake valve closed. So it's 60 degrees after this 540-degree mark. 60 degrees later, the intake valve closes. But if we look at our suspect cylinder, 127 degrees is where the intake valve closes. So there's almost a 70-degree shift, 75-degree shift in timing. And that's 75 crankshaft degrees, which is roughly, hold on, let me do that math one more time. I'm pulling up my calculator. 127 minus 60 leaves 67. So it's 67 crankshaft degrees, which is about almost 34 camshaft degrees. So,
Sorry, Brandon. I was just going to say, reference that picture as well. If you just go back there, like I say, if you're comparing these two images together, and if you look at the 360-degree mark, you'll notice on the bad cylinder, so bank two, that the intake pull for that cylinder is a lot later than that 360-degree mark compared with our good cylinder. You'll see it's roughly on the sort of the 360-degree mark. So you can see quite clearly there, that's the intake valve opening event around that area. So you can clearly see we have a difference in intake valve time between our two banks.
for sure. And the more we see from these waveforms, Ryan, the more excited I get. The more I'll use the word confident I get that you and I are on the right track because when you've got one test that confirms something for you, that's great news. But when you've got two or three visual indicators, your relative compression test was low, your cranking intake test showed a bank-to-bank issue, your in-cylinder test showed the reason why we have low compression. Also, that you have mechanical integrity as far as within the cylinders go. Not one, not two, not three, but all four. it's almost guaranteed you're going to fix the car if you retime it correctly. And that's what I love about that. And this is pretty much sums up everything you just told me. So fast forward, right? You get back to work, you get
Yeah.
the engine powertrain down, you separate the engine, and what did you find?
So this was the thing. So it was a huge job to do. I think we recorded 30 hours, but it was more like 50 hours, I think. By the time we got in there, we had to take literally everything apart. So the rocker covers had to come off, intake plenum had to come off, gearbox off, all the casings had to come off, crank, you name it, it had to come off. We was pretty much left with a bare engine at the end of it, other than obviously the timing chains and the camshafts and the bits and bobs like that. But yeah, it was a massive, massive job. So we timed it up, and it actually, to be honest with you, statically it timed up okay, strangely, because
Meaning the chains and the timing marks lined up.
lined up, correct.
Okay.
Absolutely right. So if you timed up with the tools as you were meant to statically, you would have seen that the timing marks lined up. So if you think of it from go back to the beginning, we didn't do the in-cylinder capture and we just guessed it was timing. Could you imagine the disappointment you'd have taking a whole engine apart, timed all the marks up, and all the marks timed up, and now you're scratching your head going, that makes no sense. I'm sure it must have been timing.
Be honest with me. When you first encountered that, were you like, "What's this guy told me to do?"
Yes, yes, yeah. So yes, once I marked it all up, I thought there's yeah, yeah, I wasn't best pleased. Anyway, so if we need to determine exactly we can see it from the capture. The scope doesn't lie, is what you'll hear quite a lot. So we can see from the capture, we definitely had an intake, valve timing issue. Now, if the valve timing statically times up okay, that only really leaves us with one culprit, which was possibly the dephaser. That basically phases the intake valve timing. Now, after taking the timing chains, so we timed the engine up, obviously all the time marks lined up, so we're kind of scratching our heads thinking, well, there's only ever one thing that could cause this. So after taking those timing chains off, and further dismantling of the engine, we took the intake camshaft phasers off and spun them around. And as you can see in this picture here, what we found was this kind of dephaser pivots, or say spins, obviously when it advances timing. Now, there is a tiny little pin, metal pin, that sits in this little groove here. So when oil pressure comes in the longer path, oil pressure comes in here and then pushes a tiny little pin, and then that then moves the timing and allows for variable valve timing to commence. So what had happened, as you can see here quite clearly in the shiny part, this had worn away and was allowing the dephaser, due to the oil pressure behind the pin, to constantly be
Yeah.
advanced. So it
Mm-hmm.
was it was
The chain would move the phaser, but the phaser wouldn't move the camshaft until it fully bottomed out, if you will.
absolutely right. So that was the cause of it in the end. So we ended up replacing. We done a proper job, so we didn't just change the one and then put it back together and leave him another year, and then the other one would fail. So we ended up changing both the phases rather than just the one, and obviously put the whole vehicle back together. And the vehicle ran sweet, ran on all eight, absolutely fine. As you can see here from the capture, it's quite clear to see. Like I say, we have now 8 cylinders all firing as they should do, and all equal. If you look at the reference points between the cursors and the dots that Brandon's showing here, you'll see that they are not now all near enough equal where they should be. Whereas our initial capture, you would notice that they're quite clearly different between the cylinders. So yeah,
I do
that
want to I want to throw something here real quick, Ryan.
yeah.
Some people that are familiar, excuse me, some people that are familiar with this type of testing use a delta sensor, one that changes rapidly with changes in pressure. They use a delta sensor to capture this information where you have not You've used an absolute pressure transducer rated in pounds per square inch rather than a voltage change. So some people might say, well, these are not all entirely even, Ryan. Some are up here and
Yep.
some are down here. First of all, we're referencing the timing, not so much the amplitude. And I can explain the amplitude. If you look at this scale, from one end to the other is less than 2/10 of a pound per square inch. So this is really, really stretched out. If you were to zoom out, this would almost look like a straight line across the screen. But we are seeing these very, very, very minute changes as you've zoomed way in, and that is why this looks like such a huge difference. But it's virtually the same amount. There's almost no difference at all in amplitude, in pressure. We are simply looking at the timing. So I didn't mean to cut you off.
No, absolutely fine. Yeah, that's a perfect point. Yeah, it makes the capture a bit more easier to understand. Yeah. So like I say, we put it all back together. The vehicle starts, ran on all 8 cylinders. I was jumping for joy because I didn't just waste 50 hours of my life and not getting paid for it. So that was a good day. The customer was absolutely over the moon. They couldn't believe it. They originally was obviously tasked with a new engine, or at least that's what they thought for, 12, 13,000 more than that, just for the engine, I expect, and then obviously the actual fitting of the engine on top of that.
I've got to ask you two questions. One, at what point did you stop cursing my name? And 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 two, of course, that's a joke. But if two, were you ever able to offer your findings to the shops that condemned the engine?
So the first one, I stopped cursing you after I found that the phaser had born. That was a good point and a good day. I didn't get the opportunity to speak to the shops.
Okay.
We do, or say I do, a lot of trade work for other garages. And typically we have good relationships with these garages. They struggle with some stuff and they send some stuff our way, and they do some repair, we send repair work to them. So we all work together. And I didn't get the opportunity to speak to them, unfortunately, on this occasion, but
No
you
worries.
know, the customer was really happy. That was the main thing, really. They was happy to spend money with us, which is good. So it kept us in business, I suppose.
I love that. What a great story. And, all aspects of it. The fact that you were faced with a potential engine repair, excuse me, replacement, and you were the hero. You truly gathered information and you made a decision not on a feeling you had in the pit of your stomach or on what if I make a mistake, I better just sell the customer the whole engine to cover my rear end, so to speak, so I don't have any underlying issues. That would be the easy way to go. Just replace everything. But you didn't. You stuck with it and you gathered data. And to my point, um, would you agree? I mean, what truly have you learned? Not necessarily about the vehicle,
I mean,
but I mean,
yeah. I mean, if you think about this from a garage point of view, I guess your investment in time, all of these tests probably took me just under an hour to achieve, I think. So within an hour to take the tests and obviously speaking back and forth with Brandon to analyze, which is the part that needs to be done, which is just as important as taking the measurements. Taking time out to actually analyze the captures is kind of really the key point of anything. That there was, yeah, I mean, without doing that and getting that information, we would have been absolutely, not doing too good. But we've done it so quickly, it didn't take very long. I mean, and we had confidence. So not only did we not take very long, we had confidence in our approach and our repair. We can say categorically this engine's not damaged and we can repair it. Whereas without having this equipment and the skills to do the testing, using a mechanical gauge, for example, you would get nowhere near the depth and detail of what you can do with obviously the training and the tools, pressure transducers and oscilloscopes. So definitely invest in training is 100%. It pays back tenfold. Just on this job, obviously we got 50 hours of labor out of this job based off of I attended Brandon's one day. Actually, he flew here and presented it, to be honest with you, but his one day training course on pressure analysis, and that cost probably a tenth or a 20th of the money we recuperated using this testing method on this particular engine.
On this
And
one job.
on one job.
To your point, this is where I get the argument from other technicians who don't currently train. Well, it's so hard and it takes so long. And, how much time did Ryan spend looking at that? Even if you and I spent 3 hours, do you think your client would mind paying 3 hours of labor for analysis if it meant saving 10 to 13,000 US dollars on an engine?
Absolutely. And it's not only that. I mean, we as technicians think that we can only bill out our time if we're working on the car. Now that's not that may have been the case, a long time ago when you're, changing parts and doing repairs and stuff like that. That might have been the case. But now when you're analyzing captures and you're looking at wiring diagrams and all that kind of stuff, you need to be charging for your time every hour that you're on that car analyzing information, because that information you're analyzing is saving your customer time and obviously money down the line. That couple of hours me and Brandon put our heads together to analyze, to say that this engine mechanically is not damaged, saved this customer thousands and thousands of pounds, and they was absolutely had no problem paying the money when it come to obviously paying their bill, which was the main part for me.
And I'll tell you what, you probably got a customer for life.
Yeah.
And I'm sure they told all their friends and family about you
Yeah,
because
absolutely. Yeah.
you changed their life. I mean, it sounds silly to say it like that, but think of the repercussions of having to find another affordable vehicle that was in good condition. You
For
know,
sure.
that's a
Yeah, for
very
sure.
stressful thing. And I think you did them a tremendous service. And I applaud you for your efforts and for sticking with it, because that's not something many shops would have done.
For
So
sure.
good on you for sure.
Yeah,
Um,
I mean, we stuck at it. I mean, and not only that, it was a good learning curve as well, because really, not only did I was obviously interested in these techniques, and learning more. And without having the vehicles presented to us that have these weird and peculiar faults, we don't learn anything new. If we're always doing the same thing that we've always done, then we're always going to get what we've always got. So without actually learning something new or being presented with an opportunity of change or learning, a new technique, we'd always be doing the same thing. So not only was it good for the customer, it was also good for the shop. It was good for me as well, because I learned a lot more, and it, expanded my knowledge anyway, especially with pressure transducers and all that kind of stuff.
Beautiful. I don't want to hold you up because it's Saturday and I appreciate you taking the time spent with me. I'm really looking forward to seeing you in a couple of weeks, my friend. It's been a while. I'm looking forward to seeing everybody else out there too. New friends and old. It's going to be a blast. And I do want to thank all you for taking the time to watch this episode of Wrench Tales. I'm Brandon Steckler, technical editor of Motor Age Magazine. Ryan, thanks again for joining us, my friend. I'll
It
see
was a
you soon.
pleasure. Thank you so much.